In fact, in the middle of the bowl, it was 9 meters. It was not 9 millimeters, it was 9 meters. It's very large. And it took them a while to figure out what was going on, but eventually they started pumping in water to keep the pressure so they didn't lose any more land. But in the meantime, it is a port. They lost docks, they lost an island. And so but once they corrected this, then they went back over some areas and then backfilled to get back to the original level. And so this is what's going on here. This is a fire hydrant. They've raised it, and then they're going to fill to the level of the fire hydrant. I like this picture just because of the dogs and fire hydrant association. But there's another one that's kind of funny. In Long Beach, this is part of the daily reports for how the subsidence is doing, and not daily, but monthly city council reports. And the comment was made that we now have a deep water port because 9 meters is enough to make a deep water port. It's kind of fun. Now, I'll switch to the other side. This plot, to me, is maybe the most amazing one I could dream of showing. This is data from the United Nations Food and Agriculture Association. It's cereal yield, and lots of cereals, but the big three are rice, wheat, and corn. And it goes back to 1960. It's the blue curve, and it's a linear increase over that period of time, which is really remarkable. And what it means is that yield has outrun population increase, and it's also meant that there's really not much increase in the amount of land that's under cultivation. Now, the IPCC report does include a section on agriculture and the effects of climate change, and there are several different components that are considered. Carbon dioxide fertilization, longer growing season in high latitudes, and also on average, maybe not everywhere in Australia, but on average an increase in precipitation. These are all positive for yield on balance. And you get something like, at least in their charts, you get something like a 10 to 20% improvement depending on the cereal, depending on the study. The studies have a lot of spread in them going forward. And that would be for the my projected levels for carbon dioxide and temperature. Now, at this point, I'll sum up. For oil, gas, and coal, we'll start with that. U.S. crude oil production has followed almost perfectly a cumulative normal curve for 100 years. And at this point, I think you can say that the curve is the production history is simply not consistent with the geological survey assessments for long-term production. On the other hand, the projection for long-term world oil and gas production is entirely consistent with the reserves, and you could use either one without having a different result. For coal, what you see is that you can make a projection for long-term production from reserves very early on, before you could even dream of doing a production fit. But they've been high. I gave the example for the UK, that's 6 times too high. For Pennsylvania anthracite, it's 2 times too high. Other examples, Japan is about 5 times too high. France is about 4 times. So the average is around 4 to 1. It's a significant overestimate. Now, when we use curve fits, the conclusion, and this is the central result here, is that the projection is that for long-term production is 60% of the corresponding number for reserves. And that's consistent with the Australia projection as well. Now, the implication for climate that follows from that is that in terms of the change in carbon dioxide forcing, we probably are around 2/3 of the way to the top. And that actually gives us some limits on what policy could do. We've already, whatever damage we're doing, we've done a lot. We've done 2/3 of it. And then it also appears, based on the models, is that we could meet the Cancun equipment, or we would meet it, of a 2-degree sea rise without any climate policy at all. Thank you. That's a challenge. You know, what I've given you is, at least, and I think it's validated by the history with the comparison with the coal regions, is I've given you a year for 90% exhaustion, 60 years from now, and I've given you a total, but I can't get out of my numbers a path to that total. And my experience is when people tell me what it means, and I see a range of opinions. Some people would make exactly the statement you make. Other people would say, well, let's party for 30 years. At that point, I think there's something in you. It's something about your time frame, and I like the data are fun for me, but that part's getting into a little more personal, how you view your life, at that point, I think both conclusions could be drawn. You'd need a more serious discussion, which obviously I haven't done here about what does that mean, because my numbers aren't telling me the path to this. The one reason is I look at the mature coal regions. France peaked at 70% of the long-term production, very late in the cycle. The UK peaked at 40%. So to me, there's something else that causes where the peak happens, and I don't know how to predict it. So I back off. The 90% exhaustion years are quite consistent, and the thing I could say is that for each of the regions, by the time you get to 90%, things are dropping fairly quickly, and you really need a plan B. You can be, well, we use a different energy source, or if you don't have a plan, you're going to use less energy. That seems to be the message. But of course, that's not next year in this model. I just don't have the curve. There's nothing in the model that says the production in 5 years will be X. And my sense is I haven't seen something that's convincing to me that I could validate from historical data to give you that number.
I have a question in two parts. The first one is, I've read Duffy's books, and he uses the logistic curve.
I'm sorry, whose book?
Duffy's.
Oh, DeFace, yeah, sure.
And he uses the logistic
Yeah.
and it seems to me to be a very good model.
Now, see, we're talking world oil production here? Yeah.
In your paper, you consider some other models.
And I can, is that the first question? And then I could come back.
The question is, what made you decide this model rather than some of the others?
Yeah, I have that number called R squared that helps me pick the best long-term production. I also use it, I only use two different S curves. There's one called logistic, there's one called normal, and they differ in this quantity called kurtosis, which is how narrow the peak is. And I use the same R squared to tell me which one I like. If you actually, if you read it in detail, for DeFace is also very interested in U.S. crude oil production. The normal actually fits better for that, which is what I find too. But it's simply done the same way. The issue with the kurtosis, again, that's how peak the response is. It's an additional complication. The logistic is more spiked in terms of the annual production. The normal is more spread out. You could easily imagine, and people do advocate this would happen, things that are more spread out than a normal. The problem is the limiting case there is something that's simply flat and then 1 year it stops. That's not something you can, my curve fits will go too wild. So there's a limiting case of small kurtosis where I'm going to have trouble predicting just as a statistical problem, but obviously it can happen in principle.
And the other part's more a proposition. I've done some personal modelling on different variants of Duffy's model, and it seems to me that price plays a role, and you get more catastrophic drops if the commodity is very inelastic. If we absolutely must have that commodity, unless we can't substitute it, unless the glorious flame out, we get a sudden.
That's an I hadn't. Let me try to see if I can get to. Yeah, that's a fascinating question, and I think there's a couple or comment. There's a couple of ways I think we could. Let me see if I can bring the British one up here because that's the one where that really comes in. Okay, I don't know the French numbers. For the British numbers, if you just convert by purchasing power, the current price, the price at the Jevons's peak, Jevons's time, 1865, was about 5 shillings a ton. The current price is something that equates, according to the the conversions, to about 17 pounds a ton now. The current price is about 50 pounds a ton. So what I would argue is that probably the current price is not lower than it was before. I'm not sure I would make much out of that ratio. One thing that's interesting about this curve is that you actually cover 2 phases in British history, which were very dramatic and important for the political history also, is that you have a nationalized phase from 1946 to 1994, and then you have a private phase on both sides of those. During the national time, and maybe you can see a little pickup here during that time, it's bounded by the gray lines, there were enormous investments made by the government. After my own sense, at least on the time scale we're looking at, is they both crash. You know, you can crash whether it's private funding, you can crash where it's public funding. They had a good go at it, just no one's figured out how to do it. The other comment, which to me is also relevant to this, is the Ruhr Valley, which is underground mining like this, has a very different history. I think the Germans had seen what a hassle, headache that the British were having with labor relations, and they simply bought off the miners. They paid the underground miners still 4 times the world price for 50 years. And the interesting thing about the Ruhr is it crashes at about 10% a year, just like the British one. But even more than that, you know, all of my comparisons in the table are compared to reserves. We have no absolute, there's no heaven perspective on this. And the interesting thing is that the German reserves are much further out in terms of, I mean, there you're not talking about factors of 4, you're talking about factors of 10 and 20. And the Ruhr has produced 10 billion tons. The early reserves on that were 200 billion tons. So they're way off. And my sense of what happens there is you have to understand that this is a government policy that encourages underground mining. But unlike oil reserves, these are also government estimates in government bureaucracies. I think they're coupled. And so if you have government support, I think there's a kind of enthusiasm factor that percolates over to the reserves agency. And the German ones have been farther out than anybody. And they've had, I think, the most embarrassing retreat. In 2000, and I'm not going to get the numbers quite, I think it was the 2001 survey, they had 20 billion tons for the Ruhr. By the time you got to 2003, they were down to 200 million tons. So they dropped 99% in one. These are 3-year intervals. So my sense of it is obviously price matters. You know, in a private world, they have to make money. But it's interesting. This is different if you track something like palladium. You can see spikes of 10 to 1 in the price, and that affects things. Palladium mines are set up so when they go low, they shut down. Coal mine is a living thing. You shut it down and you aren't bringing it up again. It's rare. It's done a couple of times. And also, these are long-term contracts, so they don't have these large fluctuations. And maybe even a kind of backing off comment is you can't raise the price of oil and gas and coal by a factor of 10. The whole economy shuts down first, as we saw in 2008. It's nothing like a factor of 10 on it. So I'm not sure the price plays the same role that it does, certainly in palladium mining. There's another factor here is all the countries we're talking about are advanced, rich countries. UK, Japan, France, Pennsylvania. And one of the things that happens over time is that underground mining is still dangerous. It's dangerous 100 years ago. It's dangerous now. What you can see in each case is the countries, you know, they have an improvement in technology. In oil, you use it to get more oil. In underground coal mining, you use it to save miners. And so they've got much better safety records now. But the productivity hasn't risen to the same extent as it does in other areas. And that, I think, is the social interest in this, is the safety of the miners is a large factor in all of these countries.
So I think we'll have to leave it there.
Okay.